You're
Okay, and we're live now. Can you hear me?
okay. Yes.
Okay. Hey, folks. Thank you for joining us once again on our live stream, bi-weekly, sort of bi-weekly kind of live stream. You understand? If you know what I mean. So we're trying to make this as like interesting as possible by bringing on new people, not just you seeing my face and Rams. I know most of us are bored by now. So we have like someone very interesting here with us to talk about Tekton and Paketo Buildpacks. So I'll just quickly introduce myself. You all know me if you watch this live stream a lot. My name is Shedrack Akintayo. I'm a developer advocate at the Cloud Founding Foundation. And with me is Ram. Ram, can you just quickly say hi and,
Sure. Hey, everyone. Good morning, good afternoon, good evening, whichever part of the world you're joining us from today. Very glad to have you for what I think is one of our more interesting streams in a while. So today we're going to demonstrate some stuff that we've done with CI/CD, and we're not going to do a lot of stuff about Cloud Foundry itself, unlike our previous streams. But there's another project that has been graciously donated by VMware to the Cloud Foundry Foundation, and that's known as Paketo. Kashyap, who's joining us, is a product manager. I want to say the product manager, but I don't know if it's just him, but let's find out more from him. So he joins us from VMware. Hi, Kashyap. Thank you so much for joining us. Do you want to quickly introduce yourself before we move on?
Hey, thanks for having me, guys. So as Ron kind of said, I'm Kashyap, product manager at VMware. I work on the open source Paketo Buildpacks project and within VMware Tanzu build service.
Great. Do you mind explaining to us a little bit about what Tanzu is in general, and is it something that people can go check out somewhere?
Yeah, definitely. So a lot of us came through from the Pivotal acquisition about like a little over a year ago. So for folks who have used Cloud Foundry in the past, that sort of CF push experience, we have Tanzu application service, one of the big flagship products, as well as I kind of mentioned, I work on Tanzu build service, which is kind of the platform offering to around build packs to turn your source code into container images that could run on any kind of Kubernetes platform. And we will get a bunch of links posted in chat afterwards around this as well.
Great.
Awesome. Yeah, so basically in this particular live stream, you would not be hearing a lot from me. So just, I don't know, just be, yeah, I will not be talking a lot. I'll just be quiet and just like you are, I'm also learning. I'm also listening from, I don't know, the two experts, which is Ram and Kashyap. So I don't know, should we get right into it and so we don't stay long on this live stream? So what's the next step, Ram?
I didn't think it was possible that we could get Shedrack to shut up. So I think we should definitely do more of this topic. But
I know you're enjoying this.
nah. So yeah, I think we have like a bunch of different things to cover today, because we're going to be talking about two different projects. Obviously, one is more closely tied to what Shedrack, myself, and Kashyap do, and another is Tekton itself. So I'm not sure what the exposure of our audience is to Tekton itself, but let's just take a few minutes to introduce Tekton as well. So as the world started to move from, I don't want to sound like a Morgan Freeman monologue, but as the world started moving from doing
Yeah.
binary for deployment as immutable artifacts and doing containers and evolved into Kubernetes space, so did all of the tooling that surrounds what engineers do. So CI/CD, which again is rather crucial uh, in what developers need to deploy and have a disciplined DevOps practice, also started to evolve into what is now known as a more cloud native approach. And the sort of product that emerged out of these efforts is what we now know as Tekton. So um, historically, I think it was how the Knative project, if I'm not wrong, was doing CI/CD internally, and then they decided to productize what they did, and so Tekton was actually formed and stuff. Tekton is an open source CI/CD tool. It is governed by the CD Foundation, who are also a part of the Linux Foundation, much like the Cloud Foundry Foundation. And yeah, so the governance belongs to them. And what we are going to do today is showcase how you can make use of build packs to generate container images using workflows that are built on Tekton, and what better ways of building these containers there are than stuff that folks are used to, which is using Docker files. So build packs are slightly better in that regards, and build packs also have like a long history. um, Started about 10 years ago in 2011, fork between Heroku and the Pivotal team, who were the primary consumers of build packs technology as far as the world can tell. And then they sort of again converged into what are now known as cloud native build packs, I guess. So you'll hear a lot of these things as we progress in the stream, and it sort of ties into what Paketo is and what they do and stuff as well. So yeah, you know let's get started um, with the demo today. I'm going to share my screen. Shadrach, if you can just confirm that you do see my screen. Yep, thank you. So, yeah, like I mentioned, we're going to be talking about like Tekton and Paketo and all of these things. And so, let me quickly show what the pipeline is going to look like. So, obviously, CI/CD um, works in terms of pipelines, and this is going to be what our pipeline looks like for today. And we're going to check out like code from a remote repo, and that code will get converted into a container somewhere around here, and it will get published to a container registry. So that's the endpoint. So to get our source code into a container registry is going to be our entire flow, and Tekton is going to orchestrate all of these steps here, and it's going to make use of like these components to do some storage and retrieval and stuff like that. And we're going to see how Tekton actually goes through all of these different steps essentially. So some links and other things before we get started. So the Tekton product page itself lives here. So folks are more than welcome to take a look at this. Tekton.dev is their website. Like I mentioned, they're a part of the CD Foundation. So CD Foundation just governs a lot of open source tools in the CI/CD space, and so Tekton is one of them. Now, let's also take a look at build packs for a bit before we dive into actually making use of those. So Kashyap, do you want to share like a few details about what build packs are and what folks can do with them and stuff?
Yeah, sure. So basically, the Cloud Native Buildpacks project itself launched couple of years back, like late 2019, I believe. And all the projects around is providing tooling and an API effectively to transform your application source code into container images that could run on any kind of cloud platform. So I bet a lot of folks are probably familiar with Cloud Foundry as a whole and that sort of CF push experience when using like CF for VMs. So Buildpacks were kind of a very core piece of Cloud Foundry back in the day, just around turning your source code, running CF push, and then getting that running as like a droplet that could be deployed on any kind of cloud. So my teams and teams at Heroku and all have also been using Buildpacks for years, and around like I said, 2019 is when this idea came out to start the project. And the whole CNB project as a whole is just kind of building around the what we call the life cycle, which is just a set of APIs that are the underlying bits and pieces of how like the Buildpacks actually are orchestrated and run, as well as sets of tooling and a local kind of platform offering called the Pack CLI that we'll probably dive into a little bit during the demo, just to be able to build your apps locally using Buildpacks. So the CNB project itself is just kind of the upstream project providing all of the tooling and API and specification, like I said. And then you also have projects like Paketo under the hood, which are effectively the sets of CNB implementations for various language families and stuff. So apart from just Paketo, there are a couple other projects with also sets of open source Buildpacks. Like Heroku has their own set, and Google has their own set of Buildpacks more specific to like Google Cloud Run use cases and stuff. But Paketo as a whole, a lot of it has kind of evolved around years from developing and maintaining Cloud Foundry Buildpacks and applying those learnings into our kind of next generation of offerings. So like one of the main core things that we strive for is like modularity in all of the Buildpacks that we kind of build. I think in the demo today, I forget, Ron, if we're doing a Java app or something like that, but we'll kind of see how modular the Buildpacks themselves are and how like the overall like detection works, and on a day 2 level, how easy Buildpacks make it just to manage and operate your applications and stuff.
Awesome. Are there other, so you mentioned that Google has like a set of Buildpacks and Heroku do too. Are these also implemented on the same CNB lifecycle like Paketo is?
Yeah, so like all of them are using Google Heroku's Buildpacks. Apart from that, there are other platform offerings that have adopted cloud native Buildpacks like HashiCorp, Waypoint, DigitalOcean, App Platform, and Tanzu Build Service as well. So all of these platforms are using the cloud native Buildpack lifecycle under the hood to implement their Buildpacks. Just different flavoring and different use cases at the end of the day. Like I said, Google's Buildpacks are more kind of tailored towards Google Cloud Run specific use cases. For instance, maybe setting like GCP environment variables and stuff like that.
Nice. And is the main focus of Paketo meant to be within the Cloud Foundry ecosystem, or is it designed to be more general purpose? Use it, whoever's using Kubernetes can probably get a lot of mileage from using Paketo.
Yeah, it's very general, I'd like to say. Like, although we've evolved from Cloud Foundry in the past, really any users can use it. If you're building apps on Kubernetes, you should be able to use Paketo Buildpacks under the hood to build your apps. And for that matter, like all the other Buildpacks themselves. So I think we'll walk through like the Tecton integration, right, and how easy it is to kind of plug in a different set of Buildpacks if you wanted to. But yeah.
Okay. Cool. Yeah, let's continue with the demo. Screen is probably a little hard to read at the moment, but yeah, I think this looks better. So let's quickly revisit that diagram that I had. So yeah, basically what I'm going to show in the next few minutes is how we can set up all of the different pieces that are required, and what role sort of each of these have to play in the pipeline itself. So um, one of the first things that we need is tech. Yeah, in terms of background, Tecton basically runs on what are known as tasks. So within this entire pipeline, there's like a bunch of different tasks, and each of these tasks have a particular um, published um, sort of repo. So sorry for that, sounds very complicated, but give me 1 second to explain. So yeah, so this Tekton integration exists between Buildpacks and Tekton itself. Okay, so in order to make use of Buildpacks as the means to build your containers, um, Tekton will require that you install this particular integration um, into your sort of Tekton thing. So we'll go into some details about what this pipeline will look like, but this is sort of a good example file. So this particular pipeline assumes that you're going to create like um, a container for which you clone your repo from GitHub. You basically store it in a workspace on some storage somewhere, and then this build packs thing kicks in. So that's another task inside, and then obviously this is uh, specified to run after the git pull is complete, and then it takes like a bunch of different parameters to actually execute that. So that is the first um, that is one of the tasks that we install. So in order to install that, basically you run this command. So you apply like the build packs task onto your Kubernetes cluster that has Tekton installed. Likewise, cloning from Git, move this a bit. So cloning from Git also requires another Tekton task, and you'll have to install that before you get started using Tekton itself. Then, um, like I showed you here, there's two persistent storage areas that we need for this particular pipeline. One is like a storage volume that can store code that you clone from GitHub. And then once container images are built, you need some place for it to be stored. So this is like a Kubernetes cluster running somewhere in the ephemeral cloud. And so unless you provide like a persistent storage volume, the containers are not going to be available for you, obviously. So what we do is we create another storage, and these two resources are made available to Tekton for Git, so source code from the GitHub repository to be cloned, and then for images to be generated and stored on the cache. So let's see. So this YAML file has these two persistent volumes that it will create and it will assign. So basically, you just do a kubectl apply, and then the Kubernetes cluster will create these two persistent volumes and attach it to Tekton itself. And thereafter, stuff can be written to and retrieved when required. So that's another part of the setup itself. And then there's what is known as a service account. So service account falls slightly outside the scope of that diagram that I had shown earlier. But what I mean by outside the scope is it doesn't directly form a part of the pipeline, but in order for you to be able to do a lot of the work uh, for the pipeline, you need like a service account, because the container registry we're going to be using is a GitHub container registry. So in order to be able to write to that, you basically need this to be authenticated and things like that. So what you do for that is you create what is known as a service account on Kubernetes, name the service account, and then use the metadata um, to specify which endpoint it has to authenticate with, and then supply the required authentication thing. So in this case, we have, like I mentioned, the GitHub container registry. And although this is just a copy, you basically give your username here, and then you have to create like a personal access token with the appropriate permissions and enter that stuff here. So again, applying that is just kubectl apply the YAML file. And then I'm going to show you the pipeline itself. So at the start, we basically specify that the end of this pipeline is going to be a container by name Paketo demo, and that's going to live inside my GitHub container registry. So that's the end goal of this pipeline, and we define that upfront. Then there's basically two tasks that are carried out. The first task is called fetch repository, and this is going to be cloning like a GitHub repo. It will clone this particular repo. Let's take a look at what that is. So it's basically like a bunch of sample code that we can make use of. And yeah, we could run pretty much any of this. But then I think the project is configured to run the Java app, right? So in the second part, we actually run the build process. And here's where we first encounter the Paketo term. So basically we say, take this code from GitHub and build it using this Paketo Buildpack / builder base. Kashyap, do you want to quickly jump in and clarify what this is?
Yeah, so at a high level, the concept of a builder itself within the CNB project, a builder is a set of build packs, an ordering or configuration around those build packs, and then the operating system base image itself. So in this case, Paketo Buildpacks, the base builder is a set of, it's the base, what we call the base stack image, which is effectively just an Ubuntu Bionic image that we grab upstream from Canonical, and a set of build packs as well that are compatible with that language family. So maybe, Ram, if you wanted to open up like a separate window and just run the pack CLI a little bit, I think it would be interesting to just kind of show what's inside of one of these builders. So if you run like the pack inspect builder command, and just that name of the builder. Yep, exactly. Awesome. So now if you scroll up a little more to like the first group in there, maybe group 1 or something, we could see that all the way up top, there's the a list of every build pack itself. You can see that there's quite a lot, maybe like 50 or 60 different build packs. And then above that, you're seeing the base OS layer itself, the run image that's being used, which in this case is what we call the base operating system image. And now the last kind of important bit here as we scroll down is the kind of groups section inside of the builder, where the groups section is every single language configuration supported in a given builder. So you can see here we have several configurations around, say, a Ruby build pack, maybe different server configurations. Same thing with .NET Core. And if you keep going down, the one we care about, I think, for this app is Java itself. And you can see a kind of ordering here around build packs. So now I think this is the kind of step in that Tekton CI pipeline that you can plug in any builder, really. It doesn't need to be a Paketo builder that we ship, or Heroku or Google for that matter. Users can even, customize and define their own builders if they want, and just publish it to any registry, and they can just reference it in that pipeline. And yeah, as you're kind of running here, the pack suggest builders command, that's going to suggest all of what the CNB project calls like all of the trusted builders that you can use.
Great. Yeah, I mean, every time something says Paketo on the screen, I'm going to just call Kashyap out and say, hey, Kashyap, can you explain this for us? So please don't mind, and not to put you in a spot there, but.
Sounds good. Keep it going.
So yeah, so this pipeline basically will pick up on these two steps. And as you can see here, the output is an OCI compatible container image that gets built. And like we mentioned way up top here, it will get pushed to this registry with this name, which we can also see. So applying this is again kubectl, just apply. And I did this just before starting the demo call, so we should be good. Now, what I will also do is create this K9s thing. So K9s, if folks are not familiar, is like a nifty tool that can showcase what's actually inside a Kubernetes cluster. So the reason I bring this up is because as we start to run different things, we can see very clearly, what pods get created, and we can examine the pods for log output, and that will actually help us learn what the heck is going on inside this whole build process. So I'm just going to have that running somewhere here, so it's visible to us. And
Is there any way you can arrange your terminal side by side? There should be a way to do that.
yeah, there
I
is,
don't
but I just want the commands to be visible in the middle here. So side will go all the way to the bottom. Not a big fan of that, to be honest.
You can. I think you can clear it. You can clear the existing commands. Yeah.
Yeah, let me try that. Is this better?
Yep.
So I am just going to run this by using, but let me show you what's in the run.yaml first. So So this pipeline run will pull together all the different pieces that we were talking about for like the past 20 odd minutes, which is it'll take the service account that we generated. It'll make use of the pipeline that we have in place, do all of the authentication wherever necessary with the service account. It'll store the output of git clone in this persistent volume. It'll then run the build, and then it'll save the app image here. Yeah. And then it'll write this stuff back to the GitHub container registry using the service account that we created. So that's basically it. All right. So when I run this, which is kubectl apply this file, so you can see like a bunch of pods get created and get consumed here. Let's quickly, yep.
You know, I've been trying to figure out how K9S works. Until today, I still have not figured it out. Maybe there's something I'm doing wrong or so. Probably.
Some stuff's happening here. Pod is initializing here. So basically, the logs here tell you that this code from that GitHub repo has been checked out, and then it'll close the pod, and then we wait for this to initialize, and then it'll start running the build itself.
I wonder if you could scroll up a little in the log output. This might be a good time to kind of walk through the build process a little bit.
Let's see.
Maybe we need to wait a little.
There should be a way to toggle auto scroll this. Yeah, I think we're fine. We don't need to see Maven downloading the whole internet. So yeah, it should be fine.
It's quite a lot. So I think the first important phase here we have going on is detection itself, which is like really important part of the build pack lifecycle. This is where it's looking into the builder itself and understanding like what kind of app do I have today. So chances are, I didn't get to take a look at that sample Java app that we're building, but chances are maybe it's a compiled char file or something like that. And you can see here, all the build packs that are participating, like Bellsoft Liberica is the JVM itself, Maven, Spring Boot, and things like that, where every single build pack, like I kind of said earlier, serves one single purpose. And that's what's kind of falling in through the build process. In the next two phases there right underneath, you have like the analyzing and restore phases, where this is just kind of, it's meant for like caching purposes, looking at, does an image called Paketo demo exist already? And if it does exist, it will like grab all of that image metadata and make it available in the build process. So that way, if say, I don't know if we'll have time right now, but after we finish this build, if we wanted to make one tiny change to my app and like re-trigger the whole build, this is where you'll start to see caching improvements in the build process. Like, so for instance, if only my app image changes, the build pack layer and the operating system layer are going to remain the same throughout it. So you'll see faster rebuilds and stuff. Now, right underneath this, you have the actual build process itself, where it's taking all of those build packs that were kind of detected on, and you can see through the log output what's kind of happening. And if you keep scrolling down a little bit, I think we had a ton of logs right around just downloading all of the dependencies from Maven that are kind of referenced inside of this application. And this will go on forever because it's a large Java app. But
Because it's
once we
Maven
skip
and
through
that's
this,
how it
yeah.
is.
Are there more logs under that?
No, so I think the build is done. Let's see what's happening. Nope. I think the whole run completed. Just give me 1 second.
Yeah, we might have just missed it in the log output. I wonder if
Yeah.
it's on the registry.
Yeah, it got published a few minutes ago. Let's see if we can fetch the logs here. Should we do? Let's see. Do I have one running? I don't think so. Yeah, so the dashboard I think is a better place to look, but let me also look in here, see if these contain anything. Nope. Nope.
Were you just trying to pull up the logs for that
Yeah, I
build?
was trying to not having.
Yeah, not a big deal if not, because we could probably just grab the image that was published and take a look at some stuff on that as well.
Sure. Okay.
What are you looking for? What are you trying to do?
Yeah, so it should show us logs about the images themselves. Yeah, this one. The images themselves being created. So I think this should do, Kashyap. Um, sorry,
Oh
so
yeah,
we
this
were
is
at the
perfect.
part where, yeah, Maven was downloading the internet for us. And then,
Yeah, let's just go to the very end of it, and we could kind of see what's happening at the end.
Yeah, can you increase this font size?
becoming old, Shatra.
So
Mm.
cool. So if you scroll down a little bit more past the build process, finally we'll see the export phase here, where you can see every single build pack in the build process that participated. Those layers are getting added in, and then it will put together that final app image that you can see that the the image is saved, and it's saved to the registry that you mentioned, the Paketo demo on GitHub registry, which is pretty neat.
Cool. So I just had a question or two. So um, it says 7 out of 18 build packs participating. Um, any chance you could clear what that actually is? What are these 18 and why did it pick 7 and how does that even happen?
Yeah, so chances are, I'm not super familiar with Java, but like inside of the Java build pack ordering, there's probably a lot of what we call optional build packs inside of it. So what we look at as an optional build pack, or actually, could you just pull up the Java build pack itself really fast so we could take a look? We could do I think there's a command pack inspect build pack or something like that. And might be yeah, that one. And then this should just be Paketo Buildpacks / Java, and without the dash in it.
Like that?
I believe so. Hmm.
Yep.
Here we go. So in this itself, you can see that in that group ordering, almost all of the build packs, except for Bellsoft Liberica, which is the JVM, you need that for any Java app, are marked as optional. So the reason why a lot of things don't participate is one example might be that image labels build pack you see at the very bottom, or environment variables or stuff like that. Those are more opt-in build packs that say you want to set environment variables on your app image, or if you want to set OCI compliant image labels on your image itself, you'd have to pass some configuration itself into the build process, like to indicate that you want those build packs to participate. So that's why you're just seeing like a few of so 7 out of 18 here participate. It's just end of the day, whatever the build process detects on.
Oh, okay. So there are 18 build packs here, and basically the build pack build process is smart enough to figure out, I guess, which of these it needs and which of these it doesn't. And so it just mixes and matches based on um, what it detects, basically.
Yeah, exactly. And like I think one thing that's interesting here, if you kind of remember the old world of the Cloud Foundry Java build pack, maybe it was just one monolithic build pack with not all of this functionality, but a good amount of this functionality inside of it, which meant that if you wanted to remove one little piece, or if you want to use maybe a different JVM distribution or make tiny little tweaks, perhaps you'd have to like fork that whole Java build pack in the past. Versus now with CNBs and Paketo specifically, it's really just a matter of creating another builder config or another build pack config that references whatever like sub build packs you want inside of it. So it's very easy to like customize a given build pack just based on your general like app configuration and app use cases.
Oh, okay. Neat. Do we want to check if this container actually works somehow?
Yeah, that would be cool.
So is there like a Docker run at maybe? Okay. So this, in terms of working with container runtimes, whatever is the output from Paketo Buildpacks can just like work, right? So there's like, if I'm used to doing like a Docker build and I use Paketo instead or pack build instead, then the rest of the workflow can remain exactly the same, right?
Yeah, exactly. And we kind of saw that, I think, with the Tecton pipeline that you put together, that like perhaps if I have an existing CI/CD flow, it's just a matter of fitting in this build packs task itself into my existing like CI pipeline, which makes it like very easy just to fit into existing build process and stuff.
Yeah, I seem to have something else running on 8080. But yeah, it looks like, you know, the app started.
Yeah, kill the process. So,
I mean, we know that the container works. So, so Kashyap, what would be like some of the major differences between what gets built with Docker build versus what gets built with pack build or using Paketo inside of Tekton at the end of the day?
That's a good question. I think the first thing we saw at the very end of the process is you really didn't need to pass any configuration beyond just the Tekton build packs pipeline itself. So that might be a one-time cost of getting that set up in your CI/CD flows and just the app that we're pointing to. So we didn't really define a Docker file or anything like that saying, here's my base OS that I want, here are all the commands I want to run, here's what my final like start command might look like. So that, you know, saves some time and things like that. It's not necessarily zero configuration because we did see that like certain build packs did not participate, and like you may need to pass certain like environment variables and stuff just to set up some configuration. But I think that's the cool part about like just getting started with build packs in general, or just being able to build and having an image at the end of the day that is runnable. Now on the kind of day two side with build packs, there's a concept in cloud native build packs called rebasing itself. So when we're patching the operating system base layer, the concept of rebasing just means that the current app image we have is pointing to a given Docker image layer that's pointing to, say, a certain SHA-SUM of my operating system base image. So if there is a CVE or anything like that that Ubuntu's patching, that actual day two operation of just patching your app image at the end of the day is very simple. And it's just a matter of running like a pack rebase command. And I believe all these CI integrations like the Tekton pipeline should just have a way to configure the pipeline to like automatically rebase anytime there's a vulnerability that's shipped inside of the operating system image. I think that's a huge one in just simplifying like your day two operations and stuff like that. Apart from that, there are a couple other like very cool and interesting features that Buildpacks and Paketo specifically offer. A big one here might be like the bill of materials that we provide throughout the Buildpacks. So bill of materials are effectively think of it like a manifest of every single dependency inside of my application and everything that was used to build an app itself. So I don't know if we have time, but if you want to try to run the pack inspect image command on this image, perhaps we could like kind of take a look at what the bill of materials looks like.
Yeah, we have time. We have about 10 minutes.
Like that?
So,
oh, perfect. It's the pack inspect -image command.
Okay.
If we want to make that like JSON readable or something, we could take a look at what's going on.
Yep. 1 second.
Cool. So first off, up top there, we're kind of seeing every single build pack itself that that participated inside of the process. I think this is interesting because you're seeing things like on like line 25 and 26 there, what type of licenses are the dependencies inside of my application, are the build pack dependencies themselves using? And if we scroll down some more, we'll even see info into like all of the application modules themselves. This is all still the build pack stuff. Yeah, now in this dependency section, we're seeing all the metadata of like what we saw in the build process earlier, going to Maven Central and downloading all of the dependencies, their versions, SHA-SUMs, and things like that. So at the end of the day, it's very easy to go through if you have to and just kind of audit what dependencies are in my application and stuff like that, which is a pretty powerful feature, I think.
So this is one of those big differentiators, I guess, between what comes out of Docker build versus what comes out of pack build, right?
Yeah, I see this as a big one. And maybe the last one I'll mention before we could jump into something else might be like just the rebuilding of your application itself. Like we now have a Tecton pipeline that's set up with maybe a little more extra configuration, can monitor for changes in that app. Anytime that app changes, we can just have that Tecton pipeline trigger a rebuild. And when I trigger a rebuild, that rebuild's gonna, as we kind of talked about earlier when we looked through the build process, that rebuild's gonna benefit from caching of the app image layers themselves. So the really only the layers that changed are going to get rebuilt, which I think is pretty cool. And this is like not something that you could definitely do this stuff with Docker files, but there's just extra configuration you need to add into like every single Docker file you might have. So I think with build packs here, it's very cool that just immediately the moment you run this again, you'll just benefit from this. Oh, did you just trigger a rebuild?
Yeah, I'm just going to try, see what comes out the other end. But there's been like no change. So I'm not sure if like Tecton would even pick it up. So yeah, I'm going to try. I'll probably post this after the stream is over. But but yeah, I think we should start concluding, to be honest. Yeah, that was a lot of information, Kashyap. Thank you so much for like taking some time. But if folks want to sort of go back to learn a little bit more about Paketo itself, or reach out to you folks, what would be good resources?
So I think right after the stream ends, we'll get some links posted and stuff. We have a website, Paketo, Paketo.io, that you could go to, read the documentation, learn more about like how to get started, what's supported, things like that, as well as a fairly active Slack and like GitHub discussions threads, which we should get posted as well on live stream afterwards. Definitely encourage folks to check out the content and get started and ask us any questions if there are any issues you run into or things like that along the way. Maybe last thing I might mention is we are a open governance project. We're looking for new contributors to get started, and in general, just looking to grow the overall community around Buildpacks and get more folks trying it out. So very happy to get new community members and help them out along the way.
Cool. So that's Paketo.io, and there's a Slack that people could, that will lead people into from there. Sounds good. We'll also post the links in the description if you're watching this on YouTube. So anytime you watch, you should be able to get to those. So yeah, thanks so much for taking the time.
Yeah, sure. Kashyap, is there anything else you want to like say other than anything else?
Other than bye.
Bye.
Well, thanks for having me, guys. This is great to see just the Buildpack integrations as a whole and how it works. So as I said, definitely check out the website, content, things like that, and would love to have folks try it out and get started. Maybe pack CLI first, and then some of these integrations that are like Tecton and stuff like that. But yeah.
It's nice. Thank you everybody for staying with us today. I don't know what they overshadowed me today, so I did not get enough speaking time. I will speak to Ram about this. I did not get enough time to speak. I don't know. I was overpowered, basically. So thank you so much, guys, everybody, for coming on. If you have any questions, you can always reach out to us on. You can drop comments. We'll always check our comments. We'd see, would respond. You can also ask the Cloud Foundry official handle or the Paketo official handle if you have a Paketo specific question to ask. Or you can DM me on Twitter at coda_BLVCK or Ram, or yeah, just reach out. We'll try our best to help you and get you started with Paketo or Cloud Foundry in general. So
yeah,
that would
I hate to say this publicly, but Kashyap doesn't have a Twitter account yet. So
how's that possible? Okay.
Someday we'll get there.
Okay, folks. Thank you once again. Thank you, Kashyap, for joining us. We are coming back with more live streams. So keep checking out the official Cloud Foundry channel and also Twitter, because we'll be posting updates there whenever we have any upcoming live stream. But we have great lineup for live streams coming up very, very soon, and this is the first of its kind, and we're excited about this. So have a great evening, afternoon, morning, everyone, for whatever parts of the world they are watching this, and goodbye.